The first question on vectors today is actually a revision question. I know it looks like the same exact question from last week, but believe me, you all know I'm not so lazy. I changed up the values. I made the question slightly different. Get started. You have part A, B, and C. Draw the diagram first. I'm going to give you a 5 minutes head start on doing the question. Revision. Good luck, and don't be afraid of sending answers. Part A is asking us to find QP. That means for the first letter is where you start, and the second letter is where you finish. So I'm going to use green for that vector. So QP, I'm going to draw a line connecting Q and P, and the arrow makes a difference. Look at it, my arrow is going in the direction from Q to P. QP and PQ are two completely different things. Now, I explained that last week, right? Direction matters. So for part A, right, I'll do the working up here. I'll do it in green also, right? I'll draw a little line here. So I'll call this part A. So to find QP, we need a plan. Remember, obviously the easiest way to go from Q to P is just to walk along the green line. But I want you to pretend that line is not, this road is not accessible. So you need a backup plan. So the plan is I'm standing at Q. For me to reach P, I'm going to walk from Q to O, and then O to P. So let's put that plan down for the examiner. I'm going to walk from Q to O, that's vector QO, and then the little add sign means then I'm going to walk from O to P. It's just a substituting the values now. QO, we're walking against the red arrow. Remember, the red road is going this way. Look at the arrow for the red road. If we're walking from Q to O, we're going against that arrow. So remember, this 10i is really positive 10i. If we're walking against, I hope you all remember to change the signs. Minus 10i plus 5j. And OP is with the arrow. Remember, this 8i is really positive 8i, so it's positive 8i plus 10j. Oh, for the blue road, we are walking in the direction of the blue road with the arrow, so we don't change any signs for the blue value. All we need to do is simplify this, and we're good to go, right? Add up all the i's, minus 10i plus 8i is minus 2i, 5j plus 10j is 15j, or you can write it in nice, the fancy form, minus 2 on top and 15. Remember, the top value is automatically I, the underneath value is automatically j, but when you write it in fancy form, you don't physically write the I and j. You're not allowed to. But the top is always I and the underneath is always j. Update your diagram. Whenever you get a value for a vector, put it in on the diagram. That's for your benefit. So minus 2i plus 15j. Right, I'm looking through the answers. Some people had the opposite answer because, they went from P to Q by mistake. This question says QP. You're starting at P. Gotta be careful, right? Great. Look for your mistakes. Look for your mistakes. And we're going to work out QM quickly. I want to finish out this question quickly and, move on to some harder stuff today. All right. Now, they said M is the midpoint of OP. Midpoint just means middle. So M is over here, the middle of what? OP. Now, I explained last week, whenever you want to find the middle of something or half of something, we just divide it by 2. So the whole line here from O to P is positive 8i plus 5j. If we are only going from O to M halfway, and we're in the same direction, because the arrow pointing this way to the right, I'm not going to make any sign changes now because I'm going with the arrow. But OM, you divide everyone here by 2. So you divide the 8 by 2 and the 10 by 2. So you will get what? Positive 4i plus 5j. Now, if this is truly the middle, then if OM is 4i plus 5j, then MP is the same value. When you add up both halves, 4 plus 4, you'll get back the 8, and the 5 plus 5 to get back the 10. So let's see if we can do this question now. They want us to find QM. QM means we're standing at Q and we want to walk to M. Q is our starting point. Let me use a different color, use a kind of pinkish color here. Right. Q to M. I'll do the working over here, so I'll follow border. QM. Now, the easiest way to walk from Q to M is to walk along the dark pink line here, right? You can just walk from Q to M. But we know that's not, and it's always telling the easiest way to walk from one point to the next point. You have to pretend that road closed down. In 99% of the cases, that is what you need to pretend. Now, there are 2 ways to get the same exact answer. I'm not going to work it out both ways because last week I proved that any method you use, any path you use, you're going to get the same answer. To walk from Q to M, you can either walk from Q to O and then O to M. It's like a road, it's like a map. Or you could walk from Q to P and then P to M. I'm going to choose the first one. I'm going to walk from Q to O and then O to M. Q to O, then O to M. QO. I'm going against the arrow, so I have to make sure I change my signs. Minus 10i plus 5j. And OM is with the arrow. I'm going in the same direction as the arrow, so I'm not going to change a thing. All you have to do now is add up all the i's and add up all the j's. Look, the i's here. Minus 10 plus 4i is minus 6i. 5j plus 5j is 10j. Put it in on a diagram. The value of the vector QM is minus 6i plus 10j. Right. I'm going to give you all a minute again to work out part C. These 2 lines means the magnitude or the length of PM. Remember, P is here, M is here. PM is the opposite direction, and look at it. On the screen, you have the value of MP, but this requires PM. Don't make that a problem. When you want the opposite value, you just make the signs the opposite. 1 minute to send the magnitude of PM. Let's get it. All right. Now we're going to introduce ratios into this. Now, technically, I showed you how to draw a ratio just now. You know? Finding half of something is technically a ratio, just a real easy ratio. It's a ratio everybody here grew up doing. And at some point in your life, somebody asked you to find half of something, and you remember finding half of something means to multiply by a half or divide by 2. That's hardwired, I guess, into your brain right now. So quick review on ratios. I know we did this a few weeks ago in the Monday class. If I have a line and I tell you this line is 200 kilometers long, and I want you to divide this in the ratio 4. Sorry, I'll use this. Yeah, I'll go with 4 to 1. And the beginning of the line is P, and let's assume the end of the line is Q. And I want to divide this in a ratio 4 to 1. Let's say it have a point here. We'll call this point K. He's not exactly in the middle of the line. He actually closer to Q. And the ratio from P to K, that's this portion, to K to Q, which is the other portion, is 4 to 1. Would you be able to find the first part, PK? Remember what ratios mean? Ratios is just a different way of writing fractions. Anytime I give you a ratio like 4 to 1, fractions have a denominator. You're not seeing a denominator here. So just like in the Monday class, to figure out the denominator, you add up all the values in the ratio. In this case here is 4 and 1. 4 plus 1 is 5. So the denominator becomes 5. So PK is 4/5 of the value of the line, and KQ is 1/5. So to find PK, all we have to do is take the 200. Well, I like to put the fraction first. All you have to do is find 4/5 of the 200. And when you find 4/5 of 200, you will get 160. And to find KQ is only 1/5 of the line. So you find 1/5 of 200 and you will get 40. Just keep in mind, the concept never changes throughout maths. Ratios is just a fancy way of writing fractions. And everyone here could find 4/5 of something and 1/5 of something. In fact, your calculator doing all the hard work. Now, it doesn't matter if PQ is a simple value like 200 or a crazy what? Vector like minus 20m plus 8m. The concept is still the same. So let's try the blue question, right? Let me help you work out that blue question. But the assumption here, guys, is that you all attended the Monday class and did the ratios, right? That was obviously help you with this at some point, right? Let's get started. Look how they phrase this question, right? And they said, if OM to MA is 2 to 3, find OM, find MA, and find AM. But look at this diagram here. It don't have no capital M anyway. They give you O, they give you A, but I don't see no capital M. Capital M and common M is two different things. So the first thing you have to do is approximate where M is. When I say approximate, I literally just mean approximate. The examiner isn't going to care for a real accurate answer. OM to MA is the ratio 2 to 3. So let me put this on top here. I'm going to write it like this. OM to MA is the ratio 2 to 3. The 2 belongs to OM and the 3 belongs to MA. Which portion is bigger? And MA, because MA have 3, and OM is the smaller piece, which is 2. So if I had to approximate where M is, and I'll put M a little bit closer to O, I won't put it exactly in the middle, because if I put it exactly in the middle, that suggests that O to M is the same distance as M to A. So to make it realistic, you put the OM slightly closer to O, because OM is a slightly smaller portion. Everyone do that for me. Take them up to there, take them up to there. Right. Put in M. The examiner just wants a approximation. If you put it in the middle, I could see the examiner getting a little bit irritated by that and taking away a mark. Right? It shows that if you put M in the middle, then that shows you totally ignored that OM was a slightly smaller part and MA was a slightly larger part. What about the fraction? If the ratio is 2 to 3, 2 plus 3 is 5. So that means OM is really 2/5 of the line and MA is really 3/5 of the line. Let's do part A. To find OM, remember OM is what fraction of the entire line? 2/5. What's the value of the entire line in this direction? Minus 20m plus 8m. So to find OM, just take 2/5 and multiply by what? Minus 20m plus 8m. If you don't like fractions, 2/5 is the same thing as 0.4. Just multiply everyone in the brackets by 0.4. And you will get this. That's the one. You will get minus 8m plus 3.2m. That's the answer. From O to M, this portion alone, the portion that I just put in red, is minus 8m plus 3.2 common n. Everyone take down up to there. Now, we can do part B, sorry, just as easily, right? MA is just the other portion, right? And look at it, they're going in the same direction, right? We don't have no sign changes to make. So MA could be like the green portion here, right? I will highlight it. MA is 3/5 of the line. So we're repeating the same procedure, except instead of using 2/5, we're using 3/5. So 3/5 of minus 20m plus 8n. If you don't like 3/5, that's the same thing as 0.6. 0.6 by minus 20, so 0.6 by minus 20 is minus 12m. And 0.6 by 8 is 4.8n. Look at it. We have this portion now. MA is minus 20m plus 4.8n. Okay? Could you all send the answer for part C for me? I want to see if you all remember the trick. When you finish take down that, send the answer for part C for me. I'll give you a hint. Part C barely has any working to do. Barely has any working. Very easy. Let me write the answer here quickly and use a nice little orange. For C, I ask you to find AM. Isn't AM the opposite direction of MA? MA is the green value. So AM, we just have to make what? The signs the opposite. So instead of it being minus 12, it's positive 12m. You can put a positive in front if you want. It's a good idea to put it. And this becomes minus 4.8m. Look for your mistakes. Look for your mistakes. So we're going to apply ratios now to an actual whole question. This wasn't a whole question. I have no way this can be a whole question in the exam. Right, let's see how this question is different. Good luck with this question. Now you'll notice I didn't give it a normal form. The value from O to P in that direction is 24 over minus 40. Remember, the top value is what? Automatically I and the underneath value is automatically j. If this confuses you and you want to rewrite it like this, 24i minus 40j, you can in the exam, right? But I'm going to try to work it like this so some people can get accustomed with the fancy form, right? In case the examiner says, and this has happened before, they will say work the question in column form. This is column form. When you write it as a vertical column. If the examiner says you have to work the answer in column form, you have to leave everything like that. You can't write it horizontally, showing the I and J. Good luck. I've given you 5 minutes. That should be more than enough. Answer. All right, let me get the fractions down first. Now, you don't see the letter K, but OK and KP. So K is somewhere in between O and P. OK is the slightly smaller piece. You see the first number is 3, so it belongs to the first portion, and 5 will go here. So OK is slightly smaller than KP. So to make it realistic, I would just put the K not exactly in the middle, but just slightly closer to O for realistic purposes. I'll write it here. OK to KP. The examiner said the ratio is 3 to 5. That means my fractions are, add the 3 and 5, you'll get 8. You'll get 3 8s and 5 8s. So OK is 3 8s of the entire value. Remember, this here is the entire value. So for part A, to find OK, find 3 8s of everything in the brackets, 24 and minus 40. Now, I know some of you have problems typing in the values, but if you want to keep it easy, right? Remember, you're just multiplying the 24 by 3 8 and the minus 40 by 3 8. So I'll do it in slow motion here. You just have to take the 3 8 and multiply by 24. So say 3 by 24 and divide it by 8. And then say find 3 8 of minus 40. Multiply minus 40 by 3 and divide it by 8, right? This is just for those who can't find the fractions button on calculator. 3 8 of 24 is 9. And 3 8 of 40 is minus 15. So, OK, I'm going to put the answer here, is 9 minus 15, right? If you write it as if you write it as 9i minus 15j, I will take it as correct, okay? Right, now part B is a two-step question. They're asking you to find the length or magnitude of KP. So you have to find KP first. So I'm going to start you off with the question. To find KP, you have to find how much of the line, because KP is the other portion, the larger portion, is 5 eighths of the entire line. So everyone find KP for me first. Remember, the top value is I, the underneath is J. Once you get the value of KP, then you can find the magnitude of KP. I'll give you 1 minute and then I'll jump in to finish up that question. 5 eighths of 24 is 15. And 5 eighths of minus 40 is minus 25. So remember, secretly the top is I, the underneath is J. To find the magnitude of KP, which is what the question is asking for, take the I value, square it, Must put a addition sign. Put the J value, square it, and you square root last. Yes, it is Pythagoras' theorem in disguise. Work until you get 29.15 units, right? We shouldn't, by now everyone, should be able to type in that, like resolve that. So to save time, work until you get the answer. Right. So this one here is a strange question. So I'm going to do this one, the majority of it with you. Everyone take down everything on the screen and draw the diagram as well. Now, do yourself a favor, right? Leave some space on this side here, right? Take my advice. You'll need some space here. When you finish taking it down, just raise your hands and we'll try this together. And that's the letter Q. Yeah, if you look anywhere on this diagram, you don't see the letter Q, right? You have L, it have M, and then it have N. And the first thing you might say is the examiner make a mistake. He show you where no Q is. And the minute people see like a 2, they just automatically think the middle. Because you know why people just think Q in the middle of LM? It's because a lot of times teachers do questions like myself, and a lot of times the letter is always be in the middle. So people will say, all right, let me just put it in the middle. Who cares? It does matter. They are saying that LQ is LM multiplied by 2. So in other words, to get LQ, you have to take LM and multiply it by 2. In other words, LQ is twice the value of LM. Let me draw it in for those who are a little bit still confused. You know where Q will be? Q will be here. Look at where, you know why? LQ is twice the distance of LM. Because to get LQ, you have to take the value of LM and multiply by 2. And when you multiply something by 2, it does get twice as large. So what is the value from L to Q? If L to M is minus 4a, then the whole value from L to Q is minus 8a. Because if you take minus 4 and you multiply it by 2 minus 4a, you will get minus 8a. It also means M to Q is another minus 4a. Because think about it. Minus 4a and another minus 4a is minus 8a. All right? So that is how you interpret that question. Now that you have the diagram, keep in mind, now some people are going to mix it up. They're going to ask, does the first minus 4a, is that the value for the whole line? No. Minus 4a, the black one, is for the black portion. The blue minus 4a is for the blue portion. I color-coded it. Each portion is minus 4a. With that piece of information now, find LQ and QN. Take it from there. I'll jump in 5 minutes, obviously. Part A, LQ is minus 8a. Right? L to Q is a minus 4. And our next what? Minus 4, being minus 8. Or another way of doing it, if they come and tell you LQ, they give you an equation, is 2LM. To find LQ, you could just take the value of LM, and we have the value of LM, which is minus 4a, and they are telling you multiply it by 2. Either way, you're getting what? minus 8a. Part B is pretty much easy. Qn, let me draw in what Qn is. Isn't that Qn? I know I didn't draw it too straight. But Qn means you're starting at Q and you're walking all the way to N. How else can you walk from Q to N, right? Pretend that Green Road is closed up. Find another way to walk from Q to N. Think of each letter as a tongue. You're starting, this is tongue Q, tongue M, tongue L, and tongue M. How can you walk from tongue Q to tongue N? Take 2 minutes. Take a minute, right? And send something. So I'm going to take it from tongue to tongue. To walk from Q to N, I'm going to walk from Q to M, M to L, and then L to N. Yes, it doesn't always have to be 2. It could be 3 roads we taking. The blue road, black road, and red road. Now be careful, right? If you're going against the arrow, you have to change the signs. I know some people just say, I'm going to walk from Q to L and consider this one road. You'll get the same answer, right? You will get the same answer. So anyway, let me put on my plan. Q to M, then M to L, then L to N. That's my plan. QM, I'm walking against the arrow, and for ML, I'm walking also against the arrow. So for the whole top, we're walking against the arrow. So we have to change the signs, right? For both of them. Notice I changed both of them to positive. And then when it's time to walk from L to N, we are going with the arrow. We don't need to change the sign of that 5b. It's still positive 5b. So the answer is 8a plus 5b. A lot of people, I think, had that answer. Let me just double check. Yep. A lot of people are having it. Right? Remember, they never ask you to find the length of Qn. And also, for those who try to find the length of Qn, that's an impossible question. Any 2 letters are A and B. I thought you could only find the length of a vector if it's I and J. This is the end of the question, guys. They just ask you to find regular, boring Qn. They did not ask you to find the length. Right? So some people are happy they got it correct. Take it down, take it down. All right. So before we move on, I need to review factorization. So I'm hoping you all did the homework, so this won't take too long to just revise, right? Obviously, guys, I can't spend time revising homework, right? But I'm willing to put a 5 minutes into this. So in vectors, there's a small part where you need to factorize in order to get out the question. So let me just refresh your memory. When you're factorizing, like if you want to factorize minus 4a plus 12b, sometimes people know what to pull out, and then sometimes you don't know what to pull out. Like if you're pulling out 4 or 12 or 2 or 3. If you're not too sure what to pull out, just look at the first item, A, the first letter, and just ask yourself what number touching that. I don't know if you all know this, but in factorizing, you can pull out any number in the world. Like, most people think if I give you 2a minus 8b, The most logical thing to factorize out is the 2, right? So if you pull out the 2, that really means you're visiting everybody here and dividing them by 2, right? So you get 1a minus 4b. Now, if I ask 100 people to factorize that question, most people will pull out 2, right? But you know you don't have to pull out 2. That is what CXC wants you to do. It wants you to pull out or factorize out the most convenient number. But in reality, you can pull out any number you want. The truth is, if you have 2a minus 8b and you want to pull out 37, look at that crazy number. Mathematically, you're allowed to do that. That just means you're visiting everybody, and instead of dividing everybody by what you're pulling out, which was 2 from the last question, you're pulling out 27. So the answer is 2a on 27 minus 8b on 37, right? You're allowed to do that in maths. A lot of people don't know that, and that's going to become a useful tool now in maths. So if they ask me to factorize OA, I could pull out anything in the world, but this is a general technique I just use. You look at the first letter, ask yourself what touching it. -4. So here's what I always tell myself. I'm going to pull out -4. So if I pull out -4, that means I'm secretly visiting everybody here and dividing them by -4. -4 divided by -4 is +1, so you get +1a. You don't have to put in 1. +12b divided by -4 is -12b. Now, I didn't have to pull out -4. I could have pulled out +4 and get a slightly different answer that would be 100% still correct in the exam. But take my advice. Whenever you have a complicated factorization question and you ain't too sure what to pull out, just look at the first value and pull that out. Let me apply to this question. The truth is, it have no number here that could go into 4 and go into 5 flush. But let me say somebody put a gun by your head and say, hey, you have to factorize that. I don't care. Some kind of crazy maths bandit. I don't know what's going on with it. But he tells you have to factorize it. You say, okay, no problem. Just keep cool. I'm going to find something to pull out. I'm going to pull out 4. You know how I got that? I looked at the first letter, and what was the number touching it? 4. So I say, hey, I'm going to pull out 4. Pull out 4, put the brackets. That's, if you're pulling out 4, that means you're secretly visiting everybody and dividing them by 4. 4 divided by 4 is 1, so you get 1a. There's no need to put the 1. And over here, you get -5b on 4. This could simplify a little bit. Here's a. If you don't like this fraction, 5 divided by 4 is 1.25, and you put the b. Everyone take down that second example as well. That's 100% correct in the exam. Well, in maths, generally in maths, that's 100% correct. So I know you're all looking at that fractions one and like, why still have to bring fractions into it? I didn't bring it in it. CXC will give you a fractions factorization question. When you're ready to move on, just raise your hands, right? I know you have a decent amount to take down there. Right, so I need all the space to work the last one, right? So I'm getting ready to erase the middle, well, all the writing on the screen, right? So fractions is a problem when it's not really a problem. It just scare people unnecessarily. So erasing everything now. So let's say the examiner asks you to factorize this, right? How are you going to do that in the exam, right? I just putting it here. I need some space here. You ain't too sure what to pull out because you don't know what number goes into 4/3 and what number goes into 2/5. You have no idea. Take my advice. What's the first letter you see? A. What is touching A? 4/3. So guess what? Pull out 4/3. What does pulling out 4/3 means? It means you're visiting everybody and secretly dividing them by 4/3. I know it looks weird. But 4/3 divided by another 4/3 is 1. So you get 8. When they divide two same things, they cancel out. All you need to do is take your calculator. Forget the minus sign. You could do the signs in the head. You know you're going to end up with a minus sign here because here is negative, here is positive. Take 2/5 and divide it by 4/3. In case you got to use your fractions button. Or you could say it like this. 2/5 divided by 4/3. Remember in primary school, the divide will change to a multiply. And you flip the 4/3 to 3 on 4. 2 by 3 is 6. 5 by 4 is 20. So you'll get 6 on 20. Actually, this could reduce a little bit. Let me just reduce it here. 2 into 2 is 1. 2 into 4 is 2. 1 by 3 is 3. And 5 by 2 is 10. And don't forget to put back Mr. B there. Right. Or you can just use your fractions button and divide it. You're going to hear some words now. Parallel and collinear. Everybody here knows what parallel is because of primary school. Two lines, like these two blue lines here, are parallel because both of them going the same direction, right? But what does collinear mean? Collinear is a special version of parallel, right? Collinear means if you have 3 points, like if you have P, Q, and M, you notice all of them form a straight line. When 3 points line up to give you a perfect straight line, you call that collinear. Technically, this is a special version of parallel. Isn't PQ and QM going the same direction, just like how parallel lines go the same direction? It's just that two of them are overlapping each other. They're not only parallel, but one of them, not really overlapping. One starts off where the other one finishes. So it comes like, if these two lines are parallel, you see how the first line completely above the second line, they don't really have a common point. Let me say K and M grow legs now. So he grows some legs and he grows some legs. And they walk up here. So now K goes over here and M goes over here. Which part PQ finish, KM continues. It's a special version of parallel where the two lines are not only parallel, but they touch each other as well. They sort of overlap, or one starts where the other one is finished. Now, because collinear and parallel are so similar, like they share a similarity. In maths, right? Sometimes the examiner will ask you to prove that two lines are collinear or two lines are parallel. To prove two lines are collinear or to prove two lines are parallel, it's basically the same exact technique, the same exact piece of working you will have to do. I just want to make that clear. And the reason that it's so, the reason once again that the working is the same is because collinear is just a special type of parallel. It is parallel. So why should there be any special working for it? Take down everything on the screen. When you finish, raise your hands and, we'll take it from there. Portions of a line are parallel or collinear. It doesn't matter if it's parallel or collinear. Like I said, it's the same working, right? But usually collinear, here's what to do. If they give you 3 points, A, M, and K, write down the 3 points, A, M, and K. Everyone write down the 3 points, A, M, and K, right? Now, here's what you have to do. Once you write down the 3 letters, circle the first 2 letters. Where's the first 2 letters? And the first 2 letters is A and M. Write down the value of the first 2 letters. If they have it on the diagram, what's AM? 3A minus 5B, right? They gave you that in they gave you that in the question. AM, I should have put in the arrows, my bad. AM is 3A minus 5B. And then circle the last 2 letters. Where's the last 2 letters? M and K. MK is how much? Minus 6A plus 10B. So it's like a kind of Venn diagram. Though. If you look, it looks like a kind of Venn diagram. And this has nothing to do with Venn diagrams. It just looks like a Venn diagram. So in other words, if it was 3 different letters, let me say the 3 letters were P, Q, and R. To prove collinear, you put down the 3 letters, circle the first 2. Find the value of the first 2. Lucky for us, the examiner gave us the first 2, AM. He just gave us it. He been real nice. And then you circle the next 2, which is MK. And it just so happens he also gave us that value. Now, here's the thing. Do AM and MK look the same? No, they don't look the same. Your job is to try to make them look the same through factorization. So if you all notice that it's real easy. Like if you're too sure what to factorize, remember what I told you all? What's the first value here? 3. So we're going to pull out 3. If we pull out 3, that means we're secretly visiting everybody here and dividing them by 3. 3 divided by 3 is 1. You will get A. And I'm going to leave this as 5 divided by 3 because 5 divided by 3 will give us 1.666666. I don't want to put that. So I'm going to leave it as a fraction. And all you have to do is factorize the other one also. You ain't too sure what to pull out? Just pull out the first value. So I'm going to pull out minus 6, which really means I'm going to be visiting everybody here and dividing them by the first number I am pulling out, which is minus 6. Minus 6 divided by 6 is positive A. 10 over 6, if you reduce that, you'll get 5 over 3. A positive divided by a negative is a negative. You notice inside the brackets, they look exactly the same. Once you get the 2 of them to look exactly the same inside the brackets, that's your proof. That's proof they are either collinear or parallel. In this case, they're asking for collinear, but it will be the same exact working for parallel. The moral of the story is this. Factorize both vectors until the inside of the brackets look exactly the same. The outside doesn't matter. You just need the brackets part to look not similar, but exactly the same. That's the end of the question. That's how you prove these 3 points are collinear. So, right? And now, the other question is not going to be this easy. And the only reason it's not going to be this easy is because in this question, I gave you the value of AM. I gave you the value of MK. You didn't have to work for that. You were given that. Most of the times in the exam, this value will be missing and this value will be missing. And you will have to do what? Do calculations before to get those answers. Hopefully the next question will be one like that, so you get an idea of how it really. Oh, well, do this one first. Are these 3 points collinear? Do these 3 points really form a straight line? Let me know, right? Give you a couple of minutes. So for the first one, if you ain't too sure what to pull out by now, well, I'll just repeat it again, right? Look for the first values, a half. So we're going to pull out what? A half. Pulling out a half just means you're visiting everybody here and dividing them by a half. The first one will always be easy because you'll end up with two same things. A half divided by a half is 1. So you end up with 1a. There's no need to put the 1. You just put a. I mean, if you want to put the 1, put it. You have a minus sign here. Plus, we can do the signs in our head, right? A minus divided by a positive is a minus. 4/5 divided by a half is really 4/5 multiplied by 2 over 1, right? 4 by 2 is 8. 5 by 1 is 5. So I know some of you will put this as a mixed fraction, 1 and 3/5. It's really up to you. I hate mixed fractions, right? I have a natural dislike for mixed fractions. I like improper fractions. The next one now, what's the first value you're seeing? A quarter. I'm going to pull out a quarter. Yes. What does that mean? It means you're visiting everybody here and dividing them by a quarter. Quarter divided by a quarter is 1, so you get 1a. We have a minus sign here, that is this. 2/5 divided by a quarter is really 2/5. Divide changes to a multiply. Flip the quarter. 2 by 4 is 8. 5 by 1 is 5. Hey, we get it to be exactly the same. The signs are exactly the same. The values are exactly the same. So these 3 points are collinear. P, Q, and M are collinear. Okay, so a lot of people, well, got it wrong. So take down the working, right? If you want to put it as a decimal, 1.6b, feel free. The examiner won't care. The only thing the examiner doesn't want you to do, you see, when you have decimal as a reoccurring value, put the fraction. Nobody likes reoccurring decimals. Just put the fraction and leave the fraction, right? Which means we could start past papers. Now, I know now is probably a real bad time to say, yeah, let me start past papers. It's almost at the end of class. You're drained for energy, right? But let me at least just see what the first one look like, right? Yeah, let me at least see what the first one look like. Oh, by the way, parallel vectors have the same exact value. Like if two vectors are parallel and have the same length, they have the same exact value. For example, if I have a vector like this, and his value is 2a, and then I have another vector down here. I know I did this last week, but let's fresh remember. If these two vectors are the same length and are parallel, like they use the parallel symbol, then the value of this vector is also 2a. I mentioned that last week, but that's quite last week. Let's try this question. It has 4 parts: A, B, C, and D. I know D is tucked away here. You might not be able to see it. But here what now? Spend 5 minutes, draw the diagram, try the question. And let's see if you get your first official past paper question correct. Now, OC and AB are parallel, and this is a parallelogram, right? So not only are these two vectors parallel, but they have the same exact length. So without any calculation, the value from A to B is also 2A minus B. It's literally that simple. Now, the second one tried to trick you. This vector and this vector parallel. But look at the direction of the arrows, and the arrows make a difference. So that means OA and CB are the same value. So CB, let me put it in on the diagram. CB and OA, because they are parallel and have the same length, they have the same value. But the examiner moved real sneaky. He didn't ask you for CB, he asked you for BC, the opposite way. But we ain't gonna fall for that trick. If we know the value of CB is minus 10B, then the opposite way, we change the sign. So it's positive 10B. Simple as that. The next part of the question asks us to find OB. Let's connect O to B. There are two ways we can, well, there are three ways we could go from O to B. We could walk the red road, which doesn't have a value, and that's the easiest way. So we're not going to use that way. In fact, it's impossible to find OB by walking on a red road. So to walk from O to B, we have two choices. We're starting at O. Walk from O to A, then A to B. You could use the top roads, or you could use the underneath road. OC and C to B. You're going to get the same answer. I'm going to use the underneath roads. Going to walk from O to C, and then from C to B. OC is with the arrow. We're not going to change a thing. And C to B is with the arrow. So we're not going to change a thing. Both of them, we didn't change a thing. 2A minus 1B minus 10B is minus 11B. Take down the answer. Take down the answer. There's one more to do. CA is almost the same thing. That's the green arrow, CA. Now, there are two ways to walk from C to A. C to B and B to A, or C to O and O to A. Anyone will give you the correct answer. I'm going to use the underneath route. C to O and then O to A. C to O, we're going against the arrow. So we have to make all the signs the opposite here. Minus 2A plus B. And then OA is with the arrow. So we don't need to change it. We keep it minus 10B. I'll put the answer here. I run out of space here. You'll get minus 2A. Positive B minus 10B is minus 9B. I know I kind of rush it there, but I know you all are tired too. Right? But take it down. Take it down.